Hello and welcome to DataStax Radio. I'm Patrick Callahan. The music team this evening is Modern Application Development. And it looks like we have a caller already. Hi there, welcome to the show. And what's your request?
Hi, this is Patrick. I've been listening to some records here in my server room recently, and I just wanted to ask for a song that I haven't heard in a really long time. I would love to hear Fourth Normal Form by the Relational Datasets.
Sure, great song. Haven't heard that in a long time myself. Here's Fourth Normal Form by the Relational Datasets.
Never thought I'd let you go. Thought everything we were was written in stone. In stone. My data needs a place to grow. 'Cause darling, we're just getting old. You know, it's time to go. I need to set my data free to meet new people and new possibilities. It took some time to see that moving on is what we need. Breaking up is hard to do. It's time to denormalize, yeah, that's the truth. Breaking up is hard to do. Time to try something new.
So, Patrick, great name. I wouldn't expect to find that on a record anymore. Do you only listen to records? Do you use Spotify at all?
Oh, yeah, I've heard of Spotify, and I know some people that use it, but I haven't tried it myself.
Well, it's a great place to go and listen to pretty much every record ever recorded. They have millions of people using it all day, every day.
Okay, all right, how is that even possible? I mean, millions of people connected to a system at the same time. I worked as a DBA in the 90s, and the only way that it worked was when we had a limited number of users, right? Maybe 100 here, like on my Sun server. But millions? Come on, that doesn't make any sense.
Well, things have changed a lot since then. Databases in particular are now designed to be driven by customers or user interactions. And if you can't scale an application and a database, how would you ever expect to be successful? Thanks for your call, Patrick. I really appreciate it.
Breaking up is hard to do. It's time to denormalize, yeah, that's the truth. Breaking up is hard to do. Time to try something new.
So, any other listeners out there? Let us know your thoughts. Looks like we have another caller on the line. Hi there, what's on your mind?
Hi there, I'm Amanda. I love that new song by Cassandra and the Petabytes. Have you heard of it?
Oh, that's one of my favorites, Amanda. Let's give this a listen. You Are My Index by Cassandra and the Petabytes.
Been through a couple of shipwrecks, so glad it's over with my ex. But we stay afloat 'cause you're my index. Seeing clearly now, don't need Windex. Zooming in once and forward and I don't need the context. I know less is more when you keep my data in check. Hey, 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 I think you're the best for me. Hey, 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 'cause you help me see. Whoa, oh, 'cause you're my index. Whoa, oh, my data's in check. Whoa, oh, 'cause you're my index. Index, index.
What a great song, Amanda. You listen to Spotify, right?
Oh yeah, I listen to Spotify almost every day. I can't believe that the previous caller doesn't listen to Spotify. I love sharing my playlist with my friends. Actually, one of my friends, she has over 2,000 followers on her playlist on songs that are all about databases. But not only is it, it's amazing that Spotify has amazing music to listen to and playlists that we can share with friends, but it's a modern application built on a modern application database. And so that's what's really interesting to me.
Wow. So Amanda, maybe you can tell us a bit more about modern applications and how they're able to achieve this incredible performance and throughput, because applications and databases scale differently than before, right?
That's absolutely right. So it all comes down to using a distributed database and then using the amazing data model. So why don't I show you? So as data has grown, this has really changed the type of databases that are used for this large data. So NoSQL databases were built for big data. And a great example of that is Apache Cassandra. So Apache Cassandra, it allows for horizontal scalability. So you can add more nodes to an existing cluster, and it's very easy. It gives you high availability and no downtime, which I'm so sorry, but I have to have my music and I need to have it all the time. And I need to have it fast. So I need to make sure that, my application is being served by a database that has really low latency, so there's no lagging with my songs. But what's wrong with the databases of the past? There's nothing really wrong with them. They were just built for a different use case, and they were built for much smaller data. And so Apache Cassandra was built to serve data fast, but in doing so, it turned data modeling all around. So many of you may be familiar with data modeling of the past. Data modeling of the past is all around normalization and third normal form. It's about having strong data integrity by only having one copy of your data in one place. So my tables are all broken apart, and I'm going to have to use joins to get my way out of it. So if you look here at this example, I have a table called songs, a table called artist, and a table called year. And so if I want to run a query that tells me who is the artist who's saying Truth Hurts and in what year was that song, I'm going to have to do, 2 joins to give me all that information and serve in that query. And joins are very expensive. So they work in the past, they were expensive in the past. But now that I need my music more quickly, I really can't afford to have those expensive joins and that high latency there when you do a join. So I'm going to turn my frown upside down and talk about data modeling with Apache Cassandra. So with Apache Cassandra, as you can see, so the past is third normal form and normalization, and the future, or the what's hip, is denormalization. So you can see here in the slide, instead, I'm just going to have one table called playlists. And in playlists, I'm going to have my ID, my title of my song, my artist, and my year, all just in one table instead of broken apart. So now if I want to do that query to gather, the artist and the year of the song Truth Hurts, I can just query the playlist table and I'll be able to get that information very quickly. So, and just a note on denormalization. So denormalization was something that was used when using these databases in the past, and that's actually where it came from. You would, because you wanted to prevent having to do those joins, you would create these tables within these older databases to get that quicker performance, even with these old school databases. But it's absolutely required with NoSQL and Apache Cassandra databases. So not only is it hip, but it's critical, and it's really cool. So another thing about data modeling for NoSQL databases and Apache Cassandra is you really have to think about your queries first. So you have to think about your access patterns, how you're actually going to pull out that data. Like for example, in that last slide, what we saw with the playlists, I'm going to have to think about the queries that I can run on this playlist. And we'll talk about that in a minute around the primary key and the where clause. But I'm going to have to think about how I'm going to access this data. So you might be thinking to yourself, how could I possibly know all the queries in advance that I'm going to need to do, from my application to my, modern application database like Apache Cassandra? It's actually not as difficult as you think. If you start actually walking through your application, how you're going to be serving your users and the information you're going to be sending and receiving from your users, it's actually really not that difficult. It really just takes a little bit of thought and some whiteboarding with your team, and it's actually pretty easy to do. So like I said, like I promised, we're going to talk a little bit about the primary key. And no, the primary key is not a hip new band. It's actually how we're going to distribute our data across our Apache Cassandra cluster. So it's made up of various elements. So in this particular example I'm showing you first, I'm saying the partition key, which actually how I'm going to partition the data across my cluster, is the same as my primary key. They're one for one. So in this table that I'm creating playlists, which is made up of year, artist name, and song name, my primary key is by year. But what I'm showing you here, while this technically works, there's another element here, and that's neat. That is that element needs to be unique. So in this particular case, just partitioning by year, it's probably not going to give us a unique value, right? Because artists, there's many songs that are produced in 1 year, and so we can't have a year be our unique identifier. But this is just a very simple example. So let me show you a little bit, another still simple example, but kind of shows you how we start building up to create that uniqueness. So in this particular case, I'm going to have a primary key that's made up of my partition key, which again spreads my data across the cluster, and a clustering column, and how it's going to be ordering my data within those various nodes on the cluster. So in this particular case, I'm using a partition key by year, and my clustering column is going to be artist name. So if we think about it, this still probably isn't going to get us a unique value, since our artist most likely has many songs that they produce in one particular year. But since our just very basic music library and playlist, we're just going to assume that each year one artist only has one song per year. But I think you're getting the idea of how we do this. So we've talked a little bit about our primary key, denormalization, and these are things that we have to do for data modeling in these modern database applications. But let's talk a little bit about best practices. So one, make sure that when you're moving from an older database, or older relational database, and coming over to a NoSQL database, that you don't just move over your data model one for one. Like you saw, you're going to have lots of normalization, third normal form. You can't just bring that over. It's just not going to work as is. So it just won't work. You have to make sure you denormalize and do some understanding of your queries and access patterns. Also, make sure you think about one table per one query. So you don't have to worry about space like they used to have to do back in the olden days. So you should be able to, even though there may be some replication of your data across tables, that's totally fine. Also, knowing your queries in advance. So you have to know your access patterns, which we've talked a little bit. It's not as hard as you think. And also, you have to think about the where clause. So the where clause is how you're actually going to be able to query that data that you've put into these denormalized tables. And so you're going to have to use that with every single query. There's no select star on a NoSQL or Apache Cassandra database. And just getting back all the results. You're going to have to figure out where your data is partitioned and pull it out by that unique identifier that we were generating with our primary key. So denormalization is your friend. So I hope that was helpful. I hope you learned something about data modeling for a distributed data application.
Incredible. I just learned how to build a distributed data model. Thank you so much for your time, Amanda.
Awesome.
Whoa, 'cause you're my index. Whoa, my data's in check. Whoa, 'cause you're my index. Index.
It's so amazing how far we've come and what modern applications have been able to achieve due to distributed architecture. So what do we think is next? Let me know if you have any thoughts or ideas on the topic. Obviously, everything's moving to the cloud, and we now have architectures like microservices and execution models like serverless, which makes developer velocity a lot quicker. And I believe we have another caller on the line. Hi, what's your name?
Hi, I'm Patricia, and I'm really interested in the songs and the topics tonight. I'd like to request Above the Clouds by the Futures.
Oh, I don't know that one myself. It's a new one for me. Let's have a listen. I really like that. Tell us a bit more about yourself, Patricia.
Well, I love listening to fresh music, something that's out of the box. And I was listening to Amanda talk about modern databases and about how they scale and distribute data. And it's all pretty cool, but I work on creating modern cloud apps. And to be honest, I don't really care much about databases. I only care about the data. I want to access data at any granularity and as fast as possible. And I want the flexibility to be able to get it in JSON or XML or any other format that I want. And besides, let's be real, who wants to know how to talk to a database? Or where the database is, or what the schema or the data model is? Just give me an endpoint and an API and let me go. The fastest way to get my app working is to make that data available from day one.
So just show me the data. That the future, Patricia?
Absolutely. And it's what we're working towards using APIs like GraphQL and gRPC. It makes my life a whole lot easier. Databases like DataStax Astra have REST and GraphQL endpoints by default that let me access and insert data.
Well, thank you so much, Patricia, for your insights and your request. Really interested to see where modern application development will go in the future, and especially from the database interaction point of view. Well, that's all we've got time for tonight. I want to thank all our guests this evening and all of you who've joined us for today's show. Thanks for listening to DataStax Radio, and hope to see you all again soon.
Cause you're my index. My data's in check. Cause you're my index. Index.
We're not gonna be able to sleep without hearing this now.
I'm gonna show this to our kids.